This is it. The final question for free response section for the 2024 AB Calculus AB exam. Free response question number 6. No calculator. Looks like we're going to need a bigger boat. That's a movie reference, kids. Jaws. The movie is Jaws. Watch it. You'll never want to swim in the lake or the ocean ever again. But let's start to cook. Tables and graphs and charts. Oh my. Ooh, that's a pretty one. F of x and g of x, and they're both swooping up like two birds flying, taking off. Okay, let me read question 6. The function f and g, they are defined by f of x is x squared plus 2, and g of x is x squared minus 2x, as shown in the graph. Shown in the beautiful, beautiful graph. 6a says, let R be the region bounded by the graphs f and g. Here's R. From x equals 0 to x equals 2 is shown in the graph. Write, but do not evaluate an integral expression that gives the area of region R. Oh man, you should thank your lucky stars, children, that you got one so easy. Now look it is top curve minus the bottom curve. That's it. That's it. So let's integrate. Our bounds go from 0 to 2. Okay. The top curve is this one here. The top curve is f of x. So I'm going to write f of x, okay, minus the bottom curve, which is g of x. Okay. Let's not forget, if you don't put the dummy variable, it will be wrong. Now, that's your answer. You're done. Now, someone told me, I was having a discussion about this, and someone said, okay, and I guess this is kind of overkill, but someone said, and someone might have this question, what about this little area here? Since it's under the x-axis, isn't that considered negative? And shouldn't we take the absolute value of f of x minus g of x? First of all, no, you don't have to do that. You can get away with it for this problem. Let me explain. With a little graphic, children. Okay, so if I have this here, and let's say I have a graph that comes up here, and a graph that comes way down here, right? And I want the area here to here. Okay, let's say for conversation's sake, this is at 4, and this is at -3 on the y. Okay, that's clearly a distance of 7. All right, that's what the subtraction is. If you look on the right side of the screen here, you see how I subtract top minus the bottom? The top is 4, and I subtract the bottom, which is -3. What happens when I subtract a negative? It's a super plus. It turns to 7. Okay? But if you happen to do the absolute value of this, okay, it will still take 7 and give you the absolute value of 7, which will remain 7. So you could get away with it for this particular problem. However, you don't need them. And we're done with 6A. 6B. Let S, okay, now we're moving on to S, be the region bounded by the graph of G and the x-axis from 2 to 5. All right? As shown in the graph. Region region S is the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis is a rectangle with the height equal to half of its base. So my height is equal to 1/2 whatever the base is. Okay, so if I were to draw a rectangle here in red, That's the base. The height is half of whatever the base is. Maybe it comes up a little bit. We've got this little rectangle. All right? Base, height. Find the volume. First of all, whenever we integrate, well, I should start with this. Whenever we want volume, we integrate the area. Okay, I know I covered this in previous problems, and I believe in the review as well. But here's the thing. The area of a rectangle is base times height. I don't want to put two variables in my integral, so I'm going to substitute 1/2 times b in for my height. So I got base times 1/2 base. I don't know why I put a second equal sign there. Equals 1/2 base squared. Okay, that's the area. Okay, base times height turns into 1/2 base squared. That's what I'm going to integrate right here. So I'm going to integrate. Okay, I like to take the 1/2 on the out. Okay, I need constant. I'm going to bring out 1/2 b squared. Okay, and you could say, I guess, db here, but ultimately, we got to figure out what's the value of the base. The base is just the height to the function. So my base is going to be my function g. All right? So now I've got 1/2 the integral. Remember, we're going from 2 to 5. That's what they tell us right here. Of x squared minus 2x, that's my base, squared dx. All right, this is going to be a lot of simple algebra, so just get used to it, okay? Let's go. First off, to make this easy, I'm actually going to square this. I'm going to apply this square here. So off to the side, if I take x squared minus 2x, and I square it times x squared minus 2x, I get x to the 4th minus 2x cubed minus 2x cubed plus 4x squared. These two can combine for negative 4x cubed. I have my plus 4x squared and my x to the 4th. So this right here is what I get when I actually square this. So I still got my 1/2. I'm still going from 2 to 5 of x to the 4th minus 4x cubed plus 4x squared dx. Woo! Let's integrate. We have x to the 5th over 5 minus, that's going to be negative 4x to the 4th over 4. So the 4's cancel. That's just minus x to the 4th. 4 plus 4x cubed over 3. And I want that from 2 to 5. And oh, by the way, when everything's all said and done, I'm still going to multiply it times 1/2. So now we have some work to do. All right, and I know it says find the volume. I need to come up with a number. There's no ifs, ands, or buts about it. We don't have a calculator to do this. It would have been nice if we could have just thrown this integral in a calculator and hit enter, but we don't. So right off the bat, you might be thinking to yourself, man, I got to take 5 and raise it to the 5th power. There's a 5 in the bottom, so it's going to cancel out, okay? So it really isn't going to be too horrible. Let's start here. We have 1/2 times. Okay, we got 5 to the 5th over 5 minus 5 to the 4th plus 4 times 5 cubed over 3. That's the first one. Okay, minus, now I got to throw a 2 in there. 2 to the 5th over 5 minus 2 to the 4th plus 4 times 2 cubed over 3. So now we just got to do some, simplification. One of these 5s, this is 5 to the 1, cancels one of these, and I just have 5 to the 4th. Look what happens. I have a positive 5 to the 4th minus 5 to the 4th. Boom. Boom. Nice. 5 cubed, okay, is 75. All right, it's 5 times 5 times another 5. It's 75. But then, okay, if I want to divide that by 3, that's 25. Isn't it? Isn't it, kids? And 25 times 4, oh, no. Whoa, it's 125. I'll be okay. What did I say, 75? I'll be all right. It's 125. Times 4, that's 500. Man. 5 cubed is 125. Times my 4, that's 500. So I get 500 over 3. Minus, okay, 2 to the power of 5 is 32 over 5. Minus 2 to the 4 is 16. Plus, that's 8 times 4, it's 32 over 3. And don't forget, this is all still times my 1/2. All right, so let's get going. So what I'm going to do is, I'm going to distribute this minus sign to make life easy. I got 500 over 3 minus 32 over 5 minus 16 minus 32 over 3. I can combine these two right here. Okay? 500 minus 32 is going to give me 468 over 3 minus 32 over 5 minus 16. Why do I feel that should be a plus? When I negate a negative, that should be a plus. Okay, that something seemed off and I found it. 3 actually goes into 468 evenly. 1, 5, 3, 153. I lied, it's 156, isn't it? 468 divided by 3 goes in 1, so that's 3, it's 116, it goes in 5 times, that's 15, that's 1, drop the 8, 18, 6 times. Boom, 156. Okay, plus 16 minus 32 over 5. If I combine these, I get 172 minus 32 over 5. Whew. I think it would be easier to change this to a mixed number than to make this a fraction with a 5 in the bottom. 172 minus 5 goes into 32 6 times, the remainder of 2. So that would be 6 and 2/5. 2/5 is 0.4. There you go. 172 minus 6 is 166. Then I still got to minus the 0.4, which would make that 165.6. Yeah, I'll be okay. And then, what am I forgetting? So I got to multiply it by a half. Oh, my God. I got to divide it by 2. So, you see how I mean? This is a lot of algebra, which 2 goes into 16 8 times. 2 goes into 5 twice, the remainder 1 goes into 16 8 times. Wow. Wow. I made, as I was going, I made some mistakes that I caught. This is still times a half. I got so consumed with the simplification that I almost forgot the 1/2. That would not have been good, kids. That was a lot of work. A was simple. B is a lot of work. I think C is going to be simple as well. Last one, 6C. Write, but do not evaluate. My God. They did that for A, and now they're doing it for C as well. An integral expression that gives the volume of the solid generated when region S. There we go, region S. is rotated about the horizontal line y equals 20. Here's a horizontal line, y equals 20. Okay? So, I'm going to rotate this, which means two things. One, I am going to have, okay, from the bottom here, I'm going to have this big circle, okay, comes around. And then from the, I'll do this in purple. From here, we're going to have an inner circle. Okay, so we have circles. Remember, when I want volume, I integrate the area, right? The area of a circle is pi r squared. The thing is, the red, okay, I want this big circle, which is the red, but then I want to subtract the inner circle, which I have here in blue, which I guess might be a deeper purple, whatever. So really, instead of 1r, just like for the first problem, how it was top minus bottom, it's going to be the bigger radius minus the smaller radius squared. All right? So here, since there are two circles, it's not just a disk where I have one radius. It's a washer where I'm going to have two radiuses. So it's the bigger radius and the smaller radius. Bigger radius squared minus the smaller radius. Okay, let's pull all the stuff aside. The bigger radius goes from 20 right to the bottom. That is a complete distance of 20. Y equals 20. So my bigger radius, when I'm integrating, pi times the bigger radius squared minus the smaller radius squared. Pi. My bigger radius is 20. Minus, this is the big R. The smaller radius, okay, if I go back here, the smaller radius is just going to go from 20 to here. So I got to take all of 20, right? And I want to subtract whatever g of x is, because g of x is my line right there. Okay, so 20 minus g of x. Now, g of x is this here. So I could write it 20 minus g of x, if I want, squared. Don't forget your dummy variable. Or I could say 20 minus, this is x squared minus 2x, but you're subtracting the whole thing, so you'd have to do parentheses there. You would have to write it like this. Either one is good for the smaller radius. We're missing one thing. Don't forget, we have bounds. I want this from 2 to 5. That's it. Kids, I mean, if you want to put this in little brackets too to keep it separate from the dx, go nuts. But we are done. That was the finishing touch, the cherry on the sundae, the piece de la résistance for the 2024 free response questions for the AP Calculus AB exam. God, I love doing this, and I hope you like learning this as well, because let me tell you what, I know a lot of smart people, and I know a lot of people that are good at math. But what I don't know is I don't know anyone who's really good at math that's stupid. Okay, all the people that I know that are really good at math are really intelligent people, and you know what? So are you, because you're here trying to figure this stuff out, or at least checking your work. We'll see you. Bye-bye.